The M1A2 Abrams tank, mastering America's armored beast. Welcome back to Intel X, where we decode the world's most sophisticated military technology. If you're passionate about understanding the engineering marvels that shape modern warfare, you're in exactly the right place. Hit that subscribe button and ring the notification bell, because today we're diving deep into one of the most formidable machines ever built by human hands, the M1A2 Abrams main battle tank. Before we begin, this presentation serves as a comprehensive correction to our previous coverage of the Abrams platform. We owe tremendous gratitude to our community. Your sharp eyes caught details we missed, and your expertise helped us refine this analysis. That's what Intel X is all about: accuracy, collaboration, and respect for the truth. Picture this: 61 tons of American engineering prowess, capable of reaching speeds that defy its massive frame, armed with a cannon that can pierce through nearly 2 feet of solid steel from over 2 miles away. This isn't science fiction. This is the M1A2C Abrams, and today we're going to show you exactly how this mechanical titan operates. From the moment a driver slides into that cramped cockpit to the split second when a 120mm round screams downrange at hypersonic velocity. We'll explore 3 critical systems: the driver's unique motorcycle-style control scheme, the revolutionary trophy active protection system borrowed from Israeli innovation, and the gunner's operation of what tankers call the Cadillac, the firing controls that unleash devastating firepower. Every detail matters. Every mechanism has a purpose. And by the end of this journey, you'll understand why the Abrams remains the king of the battlefield. The driver's journey begins at a hatch on the hull's front section. Unlike the other crew positions, the driver faces a unique challenge: operating. This machine, while reclined in what veterans jokingly call the lazy chair, a semi-supine position necessitated by the tank's low-profile design. In front of the driver sits a brake pedal, but here's where the Abrams diverges dramatically from our previous coverage of the Leopard tank. There is no steering wheel, no traditional steering column. Instead, the driver grips 2 T-bar handles, an arrangement that feels more like riding a motorcycle than piloting a 60-ton war machine. These handles contain the secret to the Abrams mobility. Each grip features a twist throttle, but unlike an actual motorcycle where left and right can be controlled independently, both throttles on the Abrams rotate in unison, linked together mechanically. To accelerate, the driver twists both grips toward his body simultaneously. But here's where the elegance emerges. Steering doesn't come from the twist. It comes from pushing the entire handle assembly left or right, similar to motorcycle handlebars. When the driver pushes the handles to the left, something remarkable happens beneath the hull. The transmission automatically increases power delivery to the right side drive sprockets and tracks. With the right side now rotating faster than the left, the massive vehicle pivots leftward, its tracks describing different arc lengths around the turn's radius. Conversely, pushing right diverts more power to the left track assembly, swinging the tank to the right. It's a system called differential steering, and it's fundamental to how tracked vehicles navigate terrain. The driver isn't pointing wheels, he's commanding which track spins faster, effectively dragging the slower side around in the desired direction. To truly appreciate the M1A2C, we need to step back through time. In the 1970s, the M60A3 Patton served as America's primary main battle tank. It was reliable, proven, but increasingly outmatched by Soviet armor developments. The Patton's limitations directly sparked the development program that would birth the M1 Abrams line. By 1986, the M1A1 variant entered service with the United States Army, featuring significant upgrades over the original M1. Then came the M1A2, a technological leap that introduced digital systems, independent thermal viewers, and commanders' weaponry controls that transformed how crews fought. Today, the M1A2C represents the cutting edge, often configured with Tusk, the tank urban survival kit, a suite of enhancements specifically designed for the brutal, close-quarters combat of modern urban warfare, including mine-clearing equipment that can be retrofitted as tactical situations demand. Interestingly, the Abrams shares DNA with Germany's Leopard 2 tank. Both emerged from a joint American-German main battle tank development program that eventually split into 2 parallel projects. The family resemblance is undeniable when you study their design philo Sophies. Let's establish the physical reality of what we're discussing. The M1A2C, equipped with Tusk modifications, stretches 9.83 meters. That's 32 feet from the tip of its gun barrel to its rear exhaust grills. Width measures 3.66 meters or 12 feet in its standard configuration, but with the Tusk-2 urban warfare package installed, that expands to 4.34 meters, over 14 feet, creating a considerably broader target silhouette but providing critical protection against shoulder-fired anti-tank weapons in confined spaces. Height reaches 2.95 meters, just under 10 feet, and the combat weight settles at a staggering 61 tons. This places the Abrams among the heaviest operational tanks globally, second only to India's Arjun main battle tank. When placed alongside a human figure, the Abrams' scale becomes viscerally apparent. It towers over infantry, a mechanical predator dwarfing its operators. Compared to the German Leopard and Russian T-90, the contrast reveals divergent design philosophies. The T-90 deliberately maintains a lower profile than Western counterparts, sacrificing internal volume for reduced detectability, a compromise with significant crew comfort and ammunition storage implications. Cost reflects capability. The Russian T-90 runs approximately $4 million. Germany's Leopard commands around $7 million. The fully equipped M1A2C Abrams, complete with Tusk enhancements and all modern systems, $8 to $10 million. You're not just buying armor and firepower, you're purchasing the most sophisticated combined arms combat platform money can build. The Abrams operates with a 4-person crew, each occupying a specialized combat station. The commander sits elevated at the turret's center-top position, enjoying the best visibility and bearing ultimate tactical responsibility. To the commander's left, slightly lower, the gunner occupies his station, eyes locked on targeting displays. On the turret's extreme right sits the loader, the only crew member whose job cannot be automated, responsible for keeping the gun fed during sustained engagements. Finally, isolated in the hull's front section, the driver navigates the battlefield separated from his comrades but connected through the intercom system that's literally their lifeline in combat. The centerpiece is unmistakable, a 120mm smoothbore cannon, one of the most powerful tank guns ever deployed. Beside it, the coaxial machine gun provides suppressive fire against infantry and light vehicles, slave to track wherever the main gun aims. Mounted specifically for the gunner's use is the counter-sniper or anti-material weapon station, critical for urban environments where threats emerge from windows, rooftops, and alleyways. This gives the gunner an independent response capability without rotating the entire turret or wasting a main gun round. The gunner's primary sight features a ballistic shield cover, protecting the delicate optics from shrapnel and small arms fire while maintaining targeting capability. Atop the turret, the .50 caliber heavy machine gun provides the commander with devastating anti-personnel and light armor firepower. Crucially, this weapon can be operated remotely from inside the protected turret using the CROWS, the Common Remotely Operated Weapons Station. The commander never needs to expose himself to enemy fire to employ this weapon. Adjacent to this, the commander's independent thermal viewer represents one of the Abrams' most significant tactical advantages, the ability for the commander to scan for targets independently while the gunner engages a different threat, effectively giving the tank 2 separate eyes on the battlefield simultaneously. Step inside the turret, and the commander's station reveals itself as a sophisticated battle management center. The most prominent feature is the primary sight extension, a periscope assembly that ensures both commander and gunner maintain shared situational awareness, literally seeing the same tactical picture. To one side sits the commander's display unit, a multi-function screen presenting thermal imagery, tactical maps, and system status information. Just below, the imaging system processes input from multiple sensors, fusing data into coherent battlefield intelligence. The commander's control system serves as the nerve center. Using panoramic 360-degree optics, the commander can rotate his view independently of the turret's orientation, scanning for threats in all directions. When he identifies a target, he can designate it electronically, transmitting firing data directly to the gunner's station, a process called hunter-killer engagement that dramatically reduces the time between target acquisition and rounds on target. The CROWS integration means that while the gunner prosecutes targets with the main armament, the commander can simultaneously engage infantry or light vehicles with the .50 caliber gun, all from the protected interior, a true force multiplier in combined arms scenarios. Now we enter the realm where training meets technology, the gunner's position. Veterans call them the Cadillac, the sophisticated control handles that give the gunner command over the turret and main armament. 2 black grips dominate the control panel, ergonomically positioned for sustained operation. Above these, the smaller red switch serves one purpose, triggering the main gun. With both mechanical and electronic safeties disengaged, pressing this switch releases the 120mm cannon's Fury, an event that generates recoil forces capable of rocking the entire 60-ton vehicle. The large switch system on the Cadillac allows the gunner to traverse the turret. Press and hold, and the turret rotates smoothly, electric motors and hydraulic systems spinning tons of steel and armor with remarkable precision. The gunner can also elevate or depress the gun tube using coordinated switch manipulation, tracking targets across varying terrain and ranges. Critically, if the gunner suffers injury to one hand, the control system allows single-handed operation from either grip, a thoughtful design consideration for combat damage scenarios. Release the controls, and all movement ceases immediately. There's no coasting, no delayed response. This instantaneous stop-start capability is essential for the micro-adjustments that separate hits from misses at extreme engagement ranges. Viewed from outside during live fire, the turret's movement appears almost organic. Smooth rotation, the gun tube raising or lowering with mechanical grace, then the violent eruption as the cannon fires, the entire vehicle rocking back from forces that would obliterate anything directly behind it. One of the most critical safety features remains invisible until catastrophe strikes, the blow-off panel system. These panels cover the ammunition storage compartment in the turret's rear bustle. If an enemy round penetrates and detonates the stored ammunition, these panels are designed to blast upward and away from the crew compartment, venting the explosion's force skyward rather than incinerating the crew. It's a last-ditch survival mechanism, the difference between a destroyed tank with a surviving crew and a mobile crematorium. When properly functioning, it directs catastrophic energy away from the three men in the turret, potentially saving lives even when the tank itself is a total loss. Inside the turret, the loader operates the ammunition compartment door using a knee switch, a hands-free design that allows him to maintain grip on the heavy rounds. The door slides open, revealing the carefully organized ammunition storage, each round secured yet quickly accessible. The Heat MPT, high-explosive anti-tank multi-purpose tracer, serves as a versatile option, though not the most accurate in the arsenal. Compared to the M829 series, it sacrifices precision for flexibility. When compared to an average human, these rounds are massive, evidence of the destructive energy they contain. Upon firing, the heat round travels downrange and upon impact, detonates in a specialized manner. It creates a hypersonic jet of molten metal, focusing tremendous energy into a narrow penetration cone capable of burning through approximately 600 millimeters, nearly 2 feet of rolled homogeneous armor. The Heat MPT's effective range extends to 2,600 meters, or roughly 1.6 miles. Impressive reach for a chemical energy warhead. In contrast, the armor-piercing, fin-stabilized, discarding sabot represents kinetic energy in its purest combat form. This round pushes its effective range to 3,500 meters, 2.1 miles of lethal reach. The fundamental difference lies in their tactical employment. The APFSDS exists for one purpose, destroying main battle tanks. Its depleted uranium or tungsten penetrator rod relies on pure kinetic energy, mass and velocity to punch through armor. Against heavily armored targets, it's unmatched. However, that same characteristic creates a paradox. When fired at lightly armored vehicles, the penetrator can pass completely through without expending its energy, potentially creating an entrance and exit hole without necessarily destroying the target. The round, too specialized, becomes inefficient. Meanwhile, the heat round, while less effective against heavy armor with reactive protection, performs admirably against light armor and fortified positions. This creates a tactical dilemma. Crews must carry multiple round types, making real-time decisions about which ammunition suits each target. It's a logistical burden and a potential point of hesitation in combat. American engineers developed an elegant solution, the M830A1 multi-purpose round designed to consolidate capabilities. The gunner can program this round for 3 distinct detonation modes. Point detonate mode, ideal for armored vehicles and trucks. The round detonates on contact, maximizing damage to medium armored targets. Airburst mode, specifically designed for infantry and soft-skinned vehicles. The round detonates above the target, showering a wider area with fragmentation, devastating to exposed personnel and unprotected equipment. Point detonate with delay mode. Penetrates the target before detonating, perfect for tanks and heavily armored vehicles where you need to get through the armor before releasing the explosive energy inside the crew compartment. This programmable flexibility reduces the logistical footprint and cognitive load on crews during high-stress combat. Borrowed from Israel's Merkava tank program, the Trophy Active Protection System represents a revolutionary approach to armor, intercepting threats before they strike. The Trophy kit extends conspicuously from the turret sides, adding approximately 600 millimeters, 2 feet, to the tank's width profile. Notably, Trophy cannot be simultaneously equipped with Tusk II components due to spatial conflicts, forcing commanders to choose between urban warfare enhancements and active protection. 4 radar arrays provide 360-degree coverage around the vehicle, constantly scanning the environment. An onboard computer processor analyzes radar returns, identifying and tracking incoming projectiles. Stage 1. Radar detection and threat classification. The system determines what's inbound and whether it poses danger. Stage 2. The processor calculates intercept parameters, trajectory, velocity, optimal engagement point, and simultaneously alerts the crew to the incoming threat. Stage 3. If the system determines the threat will strike, it automatically launches countermeasure charges that detonate near the incoming projectile, destroying or deflecting it away from the protected zone. Trophy excels against rocket-propelled grenades and anti-tank guided missiles, chemical energy threats that travel relatively slowly. However, it remains ineffective against armor-piercing, fin-stabilized, discarding sabot rounds, which travel at velocities exceeding Trophy's reaction time. These kinetic energy penetrators move too fast for interception. To counter kinetic penetrators, the Abrams relies on its armor, specifically top-secret depleted uranium plates integrated into the frontal arc. The exact configuration remains classified, but the general structure is understood. Located in the turret's frontal section and the hull's glacis plate, these depleted uranium inserts provide a density advantage. Uranium is 1.6 times denser than lead. When a kinetic penetrator strikes, this density disrupts the penetrator's integrity, causing it to mushroom, fragment, or deflect rather than maintaining the needle-like coherence needed for deep penetration. The outermost layer consists of hardened steel, the first contact point for any threat. Behind this, the depleted uranium layer provides mass and density. Additional composite materials and air gaps complete the array, each layer designed to defeat specific threat mechanisms. On the exterior, particularly on Tusk-equipped variants, you'll find tiles of explosive reactive armor, blocks containing the explosive compound HMX. These tiles are arranged strategically across vulnerable areas. American engineers added a clever refinement: curved tiles layered over the boxy reactive armor blocks beneath. When an incoming shaped charge or kinetic round strikes the curved surface, it's deflected slightly and slowed, hitting the reactive armor block beneath with reduced energy. The reactive armor then detonates, disrupting the incoming threat's penetration mechanism, protecting the crew and vehicle. All this protection accumulates mass, 61 tons repars. Presents a significant mobility challenge, especially across soft terrain or damaged bridges. Traditional diesel engines would struggle with this burden while maintaining tactical speed. The solution is unconventional. Instead of a diesel engine, the Abrams employs the Honeywell AGT 1500 gas turbine, essentially a jet engine adapted for ground propulsion. The turbine delivers exceptional power-to-weight ratio, far superior to equivalent power diesel engines. This lightweight, compact power plant enables the Abrams to reach speeds up to 45 miles per hour despite its massive weight. The multi-fuel capability is a massive operational advantage. The AGT 1500 runs on jet fuel, JP8, as its primary fuel, but can also operate on diesel, marine diesel, or gasoline. In a fluid battlefield where supply lines may be disrupted, this flexibility can mean the difference between mobility and becoming a stationary pillbox. The drawback? Turbines generate tremendous heat. The enclosed engine compartment could become an infrared beacon without proper management. Engineers installed dual cooling units that extract hot exhaust air from the turbine compartment, reducing the thermal signature as much as physics allows. It's a compromise. The turbine still runs hotter than diesel alternatives, but the cooling system minimizes vulnerability to infrared-guided weapons. All that power flows through the transmission to the drive sprockets, toothed wheels that engage the track's inner surface. These sprockets, combined with road wheels and return rollers, distribute the vehicle's weight and translate rotational energy into forward motion, pulling the Abrams across terrain that would immobilize wheeled vehicles. Let's synthesize the strengths. Fire control superiority. The integrated fire control system combines stabilization, ballistic computation, laser range finding, and thermal imaging into a package that allows accurate first-round hits while moving at speed across rough terrain. Enemies are engaged and destroyed before they can effectively return fire. Thermal imaging excellence. The second-generation thermal imaging provides unmatched night vision capability. In darkness, through smoke, across obscurant-filled battlefields, Abrams crews see clearly when opponents are blind, an overwhelming tactical advantage. Mobility. Despite the weight, the turbine engine delivers speeds that allow the Abrams to redeploy rapidly, exploit breakthroughs, and avoid artillery concentrations. The ability to cross rough terrain at 45 miles per hour gives commanders operational flexibility. Protection. The Trophy Active Protection System can intercept anti-tank missiles and rockets before impact. The depleted uranium armor provides exceptional resistance to kinetic penetrators. The reactive armor disrupts shaped charges. It is layered defense in depth, each system backstopping the others. Firepower. The 120mm cannon, capable of firing advanced multi-purpose rounds, armor-piercing penetrators, and high-explosive shells, provides the flexibility to engage any target with appropriate ammunition, from fortified positions to enemy armor. No weapon system is perfect. The Abrams carries inherent weaknesses. Top attack vulnerability. Despite frontal armor excellence, the top surfaces remain relatively thin, necessary to manage weight. Modern top-attack weapons like the Lancet loitering munition or advanced anti-tank missiles that dive onto targets from above can exploit this geometric weakness. Studies suggest that the Russian Kornet anti-tank guided missile poses a credible threat, particularly the tandem warhead variants designed to defeat reactive armor and penetrate composite arrays. Cost. At $10 million per tank, the Abrams represents an enormous capital investment. The Russian T-90 at $4.5 million costs less than half. While the Abrams provides superior capability, the cost differential means adversaries can field numerical advantages. Quantity has a quality all its own. Size and weight. The Abrams bulk creates operational challenges. It's difficult to transport, requiring specialized heavy equipment transporters or rail cars. In urban environments, narrow streets become impassable. Weight restrictions prevent crossing many bridges, limiting tactical routing options. Thermal signature. The turbine engine, despite cooling efforts, generates a heat signature larger than diesel-powered counterparts. This makes the Abrams more vulnerable to infrared search and track systems and heat-seeking missiles, a vulnerability that grows as thermal weapon systems proliferate. The M1A2C Abrams represents decades of refinement, combat experience, and engineering excellence. From the motorcycle-style driver controls to the sophisticated fire control systems, from the revolutionary Trophy Active Protection to the devastating 120mm cannon, every element serves the ultimate purpose, projecting American armored power across any battlefield. This analysis corrects previous oversights thanks to our incredible community at IntelX. Your expertise drives our accuracy, and we're grateful. Next, we'll be exploring the British Challenger 2 and its advanced fire control systems, another armored legend with unique engineering solutions. If you found this deep dive valuable, demonstrate your support. Hit that like button, share this with fellow defense enthusiasts, and subscribe to IntelX for more detailed analysis of the world's most advanced military technology. Ring that notification bell. You won't want to miss what we're uncovering next. Until then, stay curious, stay informed, and remember, understanding these machines isn't about glorifying war, it's about respecting the engineering brilliance and the brave souls who operate them. This is IntelX. We'll see you in the next one.